Okay, we're going to work on section 1.5, which is solving inequalities. And this section is pretty much the same all the way through. You'll have two assignments, each with a different set of problems, but they're the same types of problems. So I'm just going to go through several and work these and solve them. This will get repetitive because they all pretty much follow the same pattern. So just like a regular equation, I'm going to move my x's to one side and all my things without variables to the other side. So subtract the 1.5 and I get 2x plus 19 is greater than or equal to negative 7. Then subtract the 19. Okay, last step is to divide by 2. So far nothing's changed. We're just basically solving an equation, but it has an inequality sign. And this would be negative 13. So x is greater than or equal to negative 13. Sometimes your x is going to end up on the right side, and then that will read differently. But I'll see if I could set one up like that. So I already put a few numbers on the graph. Here's what you need to know, though. So if you have a sign like this or like that, that is a filled circle. If you have the ones without the equal sign, that would be an open circle. So what we do to graph this is to go to negative 13, and we're going to point in the direction of numbers greater than or equal to negative 13. So that would be in this direction. And since we have an equal sign, we are going to fill that. So that's essentially what we're going to do for every problem. Okay, next example, just going to work it just like solving an equation. So I'm going to distribute this negative 3 to get negative 6x and 15 is greater than negative 6x and 9. So I will move my 6x to one side of the equation, and you'll see right here that that drops out. So it's 0 on both sides, and then I get 15 is greater than 9. And similar to what we did with different types of solutions with equations, we asked the question, is this true or false? Is 15 greater than 9? And the answer is yes. So that is a true statement. So that means that all values of x satisfy the inequality. So this number line where it says solve and graph, well, that's one we can't graph, so we're just going to get rid of it. Okay, next problem. So let's just go through each of these. Like I said, it's very repetitive as we go through it. So 4x minus 5 is less than, distribute the 2 to get 4x minus 6. And same thing. So let's subtract the 4x. And we're going to see a similar situation happen where we get a negative 5 is less than negative 6. And so ask the question when you get to that last step, is it true or false? Is negative 5 less than negative 6? And that answer is no. So that's a false statement. Those are negative numbers. So, the more negative you are, the smaller the number is. So that's a false statement, and similar to the last one, we can't graph that. So no, we'll just say the inequality has no solutions. Okay, so those are two of the weirder cases that you'll look at. So for the next example, hopefully this one is a different case, right? So negative 5 times 2x is negative 10x. Negative 5 times negative 3 is positive 15. And that would be less than or equal to 24. So similar to all of these, we're just going to subtract. 24 minus 15 is 9, and we get negative 10x. And then we divide. So this one gives us a fraction. But since we're creating our own number lines, this really isn't a big difference from the other problems. So -9/10. So choose a place. So I'll go here, -9/10. And since we're dealing in tenths, I'll make all of these negative tenths. And so we have a situation here where we have the less than or equal to, so this is a filled circle at -9/10. And then these are numbers less than or equal to that number, so numbers that are more negative, which would be this direction. Okay, so now we see one with a lot of fractions in it, but really it's the same thing as anything else. So what I'm going to do first with this one, I may have to scoot my other problem down. I'm going to say 3/4 x and 1/2 x. If we were to write that with a denominator of 4, we'd multiply the numerator and denominator by 2. Because we really want everything to have the same denominator. So I'm going to write that here. That would be 2/4 x. And then I'll move that 3/4 to the right of that, and that's less than or equal to -1. So now 3 minus 2 is 1, so we'll have 1/4 x, or x over 4. You could write 1 over 4 too, it doesn't matter. And that's greater than or equal to -1. And you can choose to clear the fraction or not. I'm going to clear the fraction. I'll use a different color so I'd multiply this by 4. I'm going to multiply this by 4, just everything by 4. So this would give us an x. This gives us 3. And that's greater than or equal to -4. And so we just subtract 3. So x is greater than or equal to -7. Okay, same thing, we go over to our number line and we're going to put just a couple of values on the line. So this would be -7, -6, -5, -4. It's easy to go wrong there because you're going backwards. And this is again a filled circle, and that's numbers greater than or equal to -7. So that would be numbers to the right. Okay, so we've had some normal answers. We're going to have some non-normal answers. So this one is one of those. So 2x plus 12 is greater than 2x, and then distribute to the 6 plus 12. So if this were an equation, you'd probably recognize by now that that's an all real solutions, all real numbers, whatever. But let's just go ahead and subtract this 2x, and we get 12 is greater than 12. And again, you're going to ask that question, true or false? Is that statement true or false? Well, 12 is not greater than 12. So this is a false statement. Okay, so if that's a false statement, then there is no graph to draw, and you just stop. So like I said before in our previous notes, all of these problems are based on true or false statements. So you get down to that last part, is it true or false? And when it's false, or if it's true in this case for inequalities, it doesn't matter. You're not going to have something to graph. It's just going to be all real numbers. Actually, let's go back to one that is, because I think you can graph ones that are all real numbers. I said you couldn't, but you can. So it's this one. So this was true, 15 is greater than 9. So the way to show that on a graph would just be, it's kind of a ridiculous thing to do, but here would be the solution. It would just be an arrow in both directions with no points on it. Okay, so if you have any questions, contact me, and we'll do a few more of these in our live sessions too. Thanks.